In this sequence of videos, we're going to discuss complex numbers. I think a reasonable place to start with the main idea of complex numbers is to go back to the most basic number system and talk a little bit about how to motivate other number systems based on the most basic number system, which is the natural numbers. Now, the natural numbers are the numbers such as 0, 1, 2, 3, and so on and so forth. Now, if you work with the natural numbers long enough, it doesn't take too long, you'll realize that if you want to find a natural number, x, such that x plus 1 equals 0, then you're out of luck. And so we invent a new number system, the integers. The integers are 0, the positive numbers 1, 2, 3, 4, 5, 6, etc., but also new numbers, which we'll call negatives. Negative 3, start there. Negative 2, negative 1, 0, 1, 2, 3. And within the integers, we have a solution to this x plus 1 equals 0, but there's no solution in the natural numbers. Okay, well then, what about solving an equation such as 2x equals 1? Well, if I want to solve an equation like this, there's no solution if you just look in the integers. So we invent some new numbers, which we'll call the rationals, or perhaps equivalently the fractions. It's a bit harder to write out the rationals and the fractions, so we'll just assume that we know what fractions are. And within the fractions, we have a solution to this 2x equals 1. It's x equals a half. Now what if I want to solve some equation like x squared equals 2? X squared equals 2 doesn't have a solution in the rationals. That is, the solution to x squared equals 2 is an irrational number. Or perhaps more accurately, there are multiple irrational numbers, but you can't find a solution in the rational numbers. And so we invented these new types of numbers, real numbers. And in the real numbers, there is a solution to x squared equals 2. However, there is no solution to x squared equals negative 1. The number system that is invented by searching for solutions to x squared equals negative 1 is called the complex numbers. So hopefully this gives sort of a natural chain of thought that leads you from the natural numbers to the complex numbers. Now, before we go on to any discussion about complex numbers and the mathematics of complex numbers, I would like to say that I think complex numbers are, how do I say this? Their perception suffers from some poor naming conventions. What do I mean by that? So we call these real numbers. And we call something in the complex numbers, there's something called the imaginary unit. And because of this, you might think that complex numbers are, first of all, not real and perhaps imaginary and perhaps have no use. And while the reality is that real numbers do have, I would say, more applications, there are applications for complex numbers as well. So don't let the naming of these types of numbers lead you to the conclusion that they're not important in the world of mathematics or science in general.